Hello, today we have a pretty interesting project. By day, I'm a teacher, and one of the projects that we're doing in school is 2-liter bottle rockets. And in order for this to work, I'm going to need a launcher designed to launch these 2-liter bottles. It works off of pressurized air. There's several available that you can buy with or that use bicycle pumps. We're going to go ahead and design one today that can be used with a bicycle pump or can also be used with a compressor. So let's go ahead and take a look at the parts real quick and then we'll start building. Alright, so the basic construction is going to be done out of this 1/2-inch PVC pipe. We're going to swell a little part of it at the end so that when the 2-liter slides on, it'll seal against it. We're going to use the twist ties or possibly some of these multicolored ones, along with a retaining sleeve that's going to make a little release for the 2-liter bottle. There are several PVC components, caps and T's. I have a couple extra. I also have a screw together joint so that I can cut it in half so it won't be the full 10-foot length. It'll be 2 5-foot pieces that can be reassembled. And then we'll have our air connection and our bicycle pump connection on the other side. A couple of regulators. You can see we rated Harbor Freight. Dedicated air hose. I needed a couple components. It was just cheaper to get this pack. And then some hose clamps. I went with these because they were hand tightenable. You can tighten them by hand, as opposed to ones that are by screw. And then some good quality duct tape, some joint glue, and that should be just about everything we need, along with a $59 pancake compressor. So 60, 70, 80, 90, 110, 120. So this is going to end up costing around $150, everything included. You might get away a little cheaper. The compressor and some of the components are optional. You can design this to just use a bicycle pump, but with 30 students in each class, I know I'm not going to sit there and pump it, and I have a feeling that the pump wouldn't last through the first class, let alone through the whole day. Alright, first thing we're going to do is try to swell the end of this pipe. You can see the 2-liter bottle fits pretty snug. We just need to swell it a little bit so that it reaches a spot where it'll seal. So we're going to mark in right about 11 inches. And try to use birthday candle. Maybe a little bit breezy out here. The idea is to cause this to melt. Okay, so now we have a slight bulge there, and I'm going to go get a paper towel to wipe off the soot. Alright, I have to say that I feel like that took longer than it should have. I'm a little concerned about the integrity, but actually it's gotten quite hard now. Oh, can't even see it. So ideally now this should produce a pretty good seal on a 2-liter bottle as we're trying to launch it. Alright, first step of joining these pipes, make sure that we have a good fit. And then the purple solvent will be used as a primer. It's basically a cleaner, takes off all of the oils that you may have put on by hand, and then we'll apply the solvent liberally to both halves. I'm sorry, the glue. And then push on and turn. I'm holding it in place because it did want to slide off. Now our next connection is going to go relatively close to the bottom. This will allow them to use a hand pump to launch. So we want that to be close to the ground. So I'm making a cut here where I'm going to tee in a connection for a bicycle pump in. We're going to need just a little bit. Pipe for that. This will be the issue, getting this to fit inside of there, but that's the idea. So let's drill us a hole and get that cap formatted for that valve stem. Alright, so we drill ourselves a 1/2 inch hole in there for our valve stem. And I think it's gonna seal. Just in case though, I'm actually gonna ever so slightly put some glue alright, there we go. Alright, next step, prime. Then we will glue. I'm going to do these one at a time. And now this last step, I'm a little hesitant putting any glue in there because I don't want it to get into the valve stem or on the valve stem, so we'll probably just limit the glue to this side. Alright, so our first connection is done. There you see. Should we decide to use a hand pump, we'll have a connection right there. Go ahead and join up our next connection. Alright, so this elbow right here is a threaded elbow. I'll place them on a table just to make sure they're square. for the rest of the connections, we'll use a little Teflon tape. And I'm going to go around once towards the edge, work my way up, and go around twice. I'll go get a crescent wrench just to kind of tighten those a little bit. Alright, that should be good. The way I envisioned this was something along those lines. So we'll cut it there and make our next connection. That'll allow our hose to hook up. Just spinning it to allow the glue to dry all the way around the joint and not drip on one side. Alright. Next we'll rig up our hose and our safety devices. You might think at this point, oh, he's not showing us the release mechanism because he's saving that for last because he wants us to watch the whole video. Well, that's not a bad idea, but the truth is I'm just avoiding the hard part. So let's see. What I thought would be happening here is that we would have the pressure regulator on the compressor. We don't want to exceed the maximum. Now there's some different info as to what the maximum is. Some websites say that the 2-liter bottles can go up to 120 psi, which technically would exceed the capacity of this compressor. But most recommendations seem to be somewhere between 50 and 70. So we are gonna not exceed 70. So we'll set the compressor to 70, and then on the compressor side, immediately exiting, is where I thought I'd have this regulator. This would just be a duplicate safety regulator that also is adjustable. So there we go. Air connection, boom, rocket shoots. So what we've done so far is I've drilled a hole in here, and I put some small type rope through it. made a little tip for. Alright, and I want this to run about the length of the device. So, right, that's going to be our retaining sleeve. Alright, so the idea is to use duct tape So I've kind of splurged here and got the good stuff. Most, if not all, 2-liters have this little retaining part, and the idea is to use these as hooks to hold on to that, and then slide the sleeve over that to hold the bottle in place. Alright, so here's where we are now with our release mechanism. Alright, let's see what we have here now. Alright, so here's the final design before testing. So maybe not final. I went ahead and tied off the excess rope down here, taped it so that it would stay. That acts as my stop on my release sleeve. I've cut two 2-liter bottles here to act as springs, and that's going to allow this to kind of stay in the right spot, release, and hopefully that'll work. So we'll go ahead and give it a try now. Alright, so this rocket is just a plain 2-liter bottle. I filled it a little past third of the way with water. Alright, let's see what happens. I'm sure I'm bound to get wet. Well, I did get wet. Okay. Daughter has volunteered her prototype rocket before it's painted, so we're gonna give it a shot, literally, and see what happens. Not good. Ready? Alright, so daughter wasn't satisfied with the first one, so I sanded down the tip of the launcher, and the second launch was a lot better. Cleared the trees on the way up, but unfortunately did not clear the trees on the way down. So she's not happy right now. Looks like she may have to design another one. But I think we're pretty much done. I'm just going to show you the release mechanism again, and then we'll edit this and put it on YouTube for all you science-loving people out there. Alright, so here's our final version. I have 2 clamps that are hand screwed because I want to adjust the tightness every time I put a 2-liter bottle on. Just to show you how that's going to work, I'll use this tip. As you bring the 2-liter bottle down, you can pull this back and then get the 2-liter bottle on to where the ties hopefully go over, and now you are set. They're all holding onto the lip. These act as safety springs to keep the slip sleeve up, and then you got all this tightened, and then as it starts to pressurize, you're going to hear it. If it breaks free, you'll hear some of the pressure, possibly even water coming out. That would be a good time to go ahead and shoot it. Otherwise, you can just wait till you have the proper pressure, and then when you pull the release sleeve down, these are loose enough to where the bottle will slide off and launch. So that's it. It does work. Alright, one last thing to show you was that I went ahead and clipped it about midway and put this joint in so that I could take it apart, and that way it'd be easy to carry and transport in a car. Alright, so there you have it. One homemade, relatively high pressure rocket launcher. Just Showed you some photos there that showed all the connections close up. If you have any questions, go ahead and leave them in the comments below. Go ahead and give me a thumbs up or share this video. I'm still in the early stages of trying to develop my classroom YouTube channel, so any kind of thumbs up, likes, sharing definitely goes a long way. I appreciate you watching, and hopefully you're either a student. Alright, so I had to edit that out. I'm not going to show you how hard I struggled to get this connection off, but now it's loose. I don't know if that shot, the pressure seized it up, or it had a little undried glue, but now that's apart. And there we go, ready for transport. And again, thanks for watching. Don't forget about the thumbs up, and I'll see you next time.